Hi guys, the topic of this video is coordinate geometry of the circle, and I'm going to show you how to find the length of a tangent from the point of tangency to a given point outside the circle. Okay, and the diagram here really helps with this, as it does everywhere on paper too. So tangent, remember, is perpendicular to the radius. So if we were given the coordinates of this point P out here, and we joined P to the point of tangency, we joined the point of tangency to the centre, which would of course be that line CT there would be our radius, and then the centre to this point P, we'd get a beautiful right-angled triangle. Okay, and hopefully you can see clearly that we could use Pythagoras if we knew the length of two of those sides to find any other one. So I've written Pythagoras here using the points in my diagram. Okay, so the length of PC squared would be equal to the length of CT, or your radius, squared, plus the length of PT squared. So let's try a question. Find the length of the tangent from the point minus 5,8, so that would be my P minus 5,8, to this circle here. And remember, coordinate geometry of the circle, it's always a good idea to write down the centre and the radius. Centre of this circle here, x coordinate, half it and change the sign, that'll be positive 2. Y coordinate, a half the y coefficient and change the sign, and that'll be positive 3. The radius, when the equation of the circle is in this form, is g squared plus f squared minus c, or is going to be equal to g squared is 4 plus f squared is 9 minus c. C is the constant in the equation of the circle, that's 3. So I get or here is root 10. Okay, now I know the length of this line here is root 10. I've got some point out here, minus 5,8. And if I connect that to the point of tangency and to the centre, I get my beautiful right angle triangle. Okay, so we know now the centre here is 2, 3. What we've been asked for is to find the length of this line here, the length of the tangent from the point minus 5,8 to the circle. So we've been asked to find that length there. I know this length is root 10. If I knew the length of the hypotenuse, then I could just do Pythagoras. I don't know it at the moment, but can I easily find it? Yes, I can. I have the coordinates of the endpoints of that line segment, therefore I can do my distance formula. Which you'll find on page 18 of your log tables. Okay, so I'm going to minus 5,8, I'm going to let that be my x1, y1. My centre I'm going to let be x2, y2. And in here then I'm going to get 2 minus 5 is plus 5 squared plus y2 is 3 minus 8 squared. That's 7 squared is 49. Minus 5 squared is 25. So the distance from this point to the centre is the square root of 74. So now over here, if I draw my right angle triangle again, I know the hypotenuse is root 74. Radius, which is over here, is root 10, and I'm going to call this side x because that's what I'm after. Okay, so by Pythagoras, the hypotenuse squared is equal to the sum of the other two sides squared. I get 74 equals 10, because when we square a third, we just get left with what's under the third. plus x squared. 64 is equal to x squared. If x squared is 64, then x is going to be plus or minus the square root of 64, which is 8. This is length, however, and we can't have negative length, so our only answer is x is 8. So the length of the tangent from this point here to the point of tangency is 8. And that's that.